In this video, we're going to look at stem and leaf graphs, also known as stem plots, line graphs, and bar graphs. So what is a stem and leaf graph? Well, a stem and leaf graph allows us to present the data in such a way that we can easily look to see which set of numbers is more frequent than others. So as an example, 23 would be a stem of 2 and a leaf of 3. The number of 432 could have a stem of 43 and a leaf of 2, or it could have a stem of 4 and a leaf of 32. So let's actually look to see what one looks like. Here's an example where we have a Park City basketball team scores at least 30 games where these values from highest to lowest. We want to construct a stem plot or stem and leaf graph. So the first thing you want to do is draw a straight line. And we're going to start with, and this is nice that it's already in order, is we're going to start with the 3. So all the ones that have 30 will follow that. So the 3 represents the 30. The 4 I'm going to write next to will represent for the 40s. We are going to put a 5 for the 50s and the 6 for the 60s. Now, because it's already in order, all I have to do then is write for 32, I'm going to put a 2 right here. For the next 32, I'm going to put a 2 next to that. And then 33, so that 3 I just represented is 33. And then I have 34, so I'll put down a 4. And then 38, so I'll put down an 8. Now I'm into the 40s, so I'm going to go ahead and put 40 here. So that's, again, that represents 4 and 0 is 40. The first number here is in the tens places. The next numbers are all digits, or the single digits. So in the ones places, so 2, 32, 32, 33, 34, and 38. And then I have 42, and 42 again, and 43, and 44, and 46, and 47, and 47, and 48, and 48 again, and 48 for the third time, and then 49. That's a lot of shots in the 40s. So now I'm going to do the 50s, and so I have 50, and then I have 50 again, and then I have 51, 52, 52 again, 52 again, 53, 54, 56, 57, and 57 one more time. And the last one I have 60 and 61. Now you can see by the way it's presented, it looks like they're more likely to shoot in the 40s than they are any other value, although the 50s are looking pretty good as well. It's unlikely they're going to shoot in the 60s based on the data that we are seeing. So we also can do side-by-side stem and leaf diagrams. Well, what's a side-by-side? Well, a side-by-side would be comparing two data sets. So there's an example in the book, and we're just going to go over it because I couldn't find one that was really quick to do for the video. So here's the example in the book, and it says these are the age in which they became president, and let me see, and then I think this is a side-by-side. So we have the age in which they became president. I wonder if we've got the age in which they died. Oh yeah, here they are. Right next to it. Here's the age in which they were president, and here's the age in which they died. So I would have to figure out what the lowest number is, and so it looks like the lowest value is 40 in the 40s. 43 was Kennedy, 46 was Grant, 49 was Polk. So it looks like 40 was the youngest for the age of presidency. So I would do a 4, a 5, a 6, and then I don't see any 70s in here. But then I'd have to look over here and say, okay, they died. Oh, this person died at 90. That's a nice age to die at. I mean, if you're going to die at old age, 90 isn't bad. So anyways, I'd have to start from 4 and then go all the way to 9 because that's the highest value. Now, on this example, what they did was, oh, I didn't actually draw it. Okay, so let's do it. So I'd have 4, 5, 6, 7, 8, and 9. And then I'd have to decide what I'm going to put on each side. So maybe this side I'd have president age. And then on this side I'd have death. Okay. And I would just go through this, and this one's not as nice because it's not ordered. But I'd start, okay, so what I personally would do is I would grab this, put it into a spreadsheet, and then order it, because the people's names don't matter, right? On this particular setup, the ages don't matter. So what I would do is I would just set this up into a spreadsheet with all of the dates, and that way I could put it in order. And that's what I did on a different sheet, and I thought I'd put this in here, but anyways. So 40, age of death, the lowest age of death was 46, which I believe was Kennedy, so 46 and 49. And the ages of inauguration was 42, 43, 46, 47, 47, 47, 48, 49, and 49. And so that's how you would do it a side by side. So this 40, or this 4 for 40 would be in the middle. And what we did in our previous examples, we started with the smallest number, and then we worked our way up to the right-hand side. And we do the same thing on the left. You'd start with the smallest number here in the very first position next to the 4, and then as you go more left, the larger numbers would be there. And so that's how you would do a side-by-side stem and leaf diagram. Now, what's a line graph? Well, what a line graph is where we've got an X and Y axis, and we are going to display the X as being the specific values of the data, and the Y axis would be our frequency. So here's an example in which we have 40 people asked how many times a year their car was in the shop for repairs. So I have to have a 0 here because there are number of times in the shop was 0. 7 people said that. So I'd go to my 0 right here, and then I'd go to 8, and I would put a dot right there. So, okay, this is about 7 right there. And then I have 1 and 10, so I'd go 1 and 10. And then I would do 2 and 14. And then I would do 3 and 9. And then I would just connect these dots, and there's my line graph. Bar graphs is another way in which we can present data. The bar graphs typically are not touching, but sometimes in certain textbooks and certain homework sets, the bars will be touching. Most of the time, though, when we're doing bar graphs, we usually have separation between them. And it's really nice for bar graphs for categorical data. So we take a look at our previous example, and we are looking at the number of times, and this is categorical. Even though there's numbers there, it's categorical, because you don't have 0.1 times it was in the car or in the shop. You don't put your car in the shop 0.5 of a time. So if we do a bar graph of the data from up above, we can see the bars here. Now, if you were to put a dot right in the tops of each one of these bars and right in the middle, you actually would have the line graph. So I'll do this in blue. So you can see these dots in blue represent the line graph we just drew, where I put the dot at the middle of the bar at the very top, and then you have a line graph. So bar graphs can represent a data set, but they can also do multiple data sets, and that way we can do a comparison. So as an example, we have this Park City is broken down into 2 voting districts, and you can see that I have the registered voter population and the overall city population. So you can see really interesting is that number 2 here, that we have number 5 here. Number 5 and 6 is really interesting, is that we have more registered voter population than we have in the overall city population. So as we come back up here, if we look at Park City is broken down into 6 voting districts. The table shows the percentage of total registered voters that lives in each district, as well as the percentage of total that lives in each district. So really interesting is that there's more people registered than there is in that city. But that doesn't mean that there's a voter fraud. That just could mean that the district includes non-city populations. That's all. And that's it for this video. Nice short video. Read through the notes. I kind of skipped through a lot of it, but time is money and videos can be long. So read through all the rest of the notes, bring in your questions that you have, and we'll see you in class.